Okay. Here's the question. I'm not going to do this one. It's a homework problem, I think. I'll do one that's similar, I think harder. I don't plan to do this, but I'm going to show you the wording. It says in the wording, ignore the mass of that top plate. Okay? And my question is, why do you have to ignore the mass of the top plate? So here's the question. 750 millimeter long spring, compressed and confined, blah, 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 can slide freely along the the 40 kilogram block is given a speed of V when it H is 2. Determine how far the plate moves downwards when the block momentarily stops after striking it. Neglect the mass of the plate. Why? This is the question. Why do you have to ignore the mass of the plate in order for this to be an energy? It's an energy. It's in chapter 14. He wants you to use energy. Why do you have to ignore the mass of the plate? Close. What happens is when you have one mass hit another mass, you will lose energy. And in order to use energy, you have to be able to figure out where did all the energy go. Okay? Like friction, like a force, like something else. And when one massive object hits another massive object, you lose energy. You don't believe that? Take your car, run it into an embankment. What happens to your car? The embankment is zero. It's got zero energy. Your car's got a bunch of energy, right? And all of a sudden, it's sitting there on the side of the road, not moving. It has no energy. Where did the energy go? It crumpled up the front end of your car. It broke your leg. That's energy, right? So you look at the wreckage. That's a crumpled up car. Where did that energy come from? It came from your kinetic energy when it suddenly left the car and had to go somewhere, and it crumpled up the car. How do you save lives in car accidents? What you do is you get the energy, the kinetic energy out of the human body. You get it out somehow in a slow, safe way. Because if you get the energy, if you take the energy out of the body quickly, bones break, hearts stop, lungs puncture, right? That's what causes the death. You suddenly lose your energy because it went somewhere. So what do? You have an airbag, right? So that you hit the airbag and then you slowly, now it breaks your nose, right? But at least you're alive. What do they do at an embankment? Have you seen these barrels? Water barrels. Water barrels. Why do they put? Number one, why do they put barrels there? Why do they fill them with water?
Because the force transfers a lot more. It disperses through more area.
Right. You got mass in the barrel in the form of water. You smack it, and what happens to that water? It starts flying. There's kinetic energy. So you got a lot of mass, and it absorbs the kinetic energy. See that? So that's where the energy goes. And so it doesn't have to deform your car. So your engine doesn't have to be in your lap. Get the idea? So that's how you save lives. You get some way, somehow, you design it so that you get the energy out of the human body slowly so that you don't break the person's bones and skull and lung collapse. Okay? All right. So whenever you have a massive object hit another massive object, you will lose energy, and it's very difficult to calculate. Right? Accident reconstructions. What you do is you say, well, it's got zero energy now, the bumper crumpled up by this much, it's probably this much energy, well, they must have been doing 120. Right? But it's tough. But anyway, finding that energy is bad. So that's why the author tells you you have to ignore the mass of the plate. So what could I do to you on a final exam? I could give you something that looks like an energy, but it has a collision between two massive objects. And then I can sit back and watch you try to use energy. Could you do this problem? Yeah, but you're going to have to use the old-fashioned way. If you did not ignore the mass, you'd have to do it the old way. Okay, you couldn't use energy because you don't know how much is lost. Questions?